Okay, so when we're adding, subtracting rational expressions, we've got to be able to combine fractions, adding and subtracting fractions, by finding the least common denominator and then writing equivalent fractions. So, first thing I do when I'm working with an expression like this or a problem like this is I need to find the least common denominator or the least common multiple of 5 and 7. That is the lowest number that 5 and 7 will both divide into. So what would that be? 35. So my new denominator is going to be a 35. Now I need to finish out writing my equivalent fractions. So I ask myself, what did I multiply by 5 to get 35? 7. So I have to multiply the numerator by 7 also. That gives us 28. And then I ask myself, what did I multiply by 7 to get 35? By 5. So the numerator will be 15. Now that I have equivalent fractions, fractions that look different but are actually the same, I can add my numerators and get 43 and keep the denominator the same, 35. Okay? So it ends up with an improper fraction. Exactly right in this case. Now, same thing on the next problem. So what is our least common multiple of 9 and 6? 18.
I did it wrong, but I got it right.
Alright, so what times 9 is 18?
2. I did it wrong.
8 times 2 is 16. Alright, what times 6 is 18?
33.
So 33.
17 over 18.
So your final answer will be negative 17 over 18.
I did it wrong, but I had to extra.
Okay? So there you go. It's not complicated. But this is what is required. This is the basics of what is required in order for us to add and subtract rational expressions when the denominators are not the same. If the denominators are the same, it makes it easier. So let's take a look at some examples. Now, all of the examples that we do today are going to have the same denominator. So that means it's much easier. You don't have to do equivalent fractions if the denominators are already the same. So let's take this one problem at a time. Let's go with x over 7 plus 2x over 7. So what is my denominator going to be when I add these up? 7. Doesn't change. Alright? And then, at this point, I would add the numerators. What do I get?
2x squared?
Nope. 3x.
Oh, because the x is the 1, right?
Yep. Okay. Now you do number 2. Okay, so what do we have?
17x cubed.
Oh, I'm glad you said that.
That's wrong.
Can you combine squares and x's? No. So 8x squared plus 9x. But you always want to ask yourself, can the expression be factored? You always factor if possible. Can this expression be factored? No. In the numerator?
Yes.
Why? Because it has a what? A GCF. X is the GCF. So when I factor this thing, it comes out to be x, and x is the GCF, and what's left is 8x plus 9, and that is all over x plus 1. Now I cannot cancel anything. I can't cancel this x in the numerator, which is a factor, with this x in the denominator, which is not a factor. X plus 1 is one thing. But I still need to write it in its factored form. There it is. There will be some instances, very few instances, where you will not write it or not have to write it in its factored form. Alright, so that's as far as it'll go. Alright, let's do number 3. Okay, let's do this one together. Alright, so the first thing that I want you to notice is that we are subtracting. Alright, the second thing I want you to notice is that the denominators are the same, which makes it very nice. This is a nice problem. It's nice because we don't have to do as much work if the denominators are the same. So let's write out our new denominator. Our same denominator. 2v squared plus 8v plus 6 Now, in the numerators, we've got to remember when I subtract an expression, you have to change the signs. Now, these parentheses did not have to be here. If they were not here, you would still have to change both signs. Because 2b minus 7 is one thing. So let's change the signs. So we're going to make this a plus, make this a minus, make this a plus. And so then I combine my like terms. So 3v plus negative 2v is 1v or just v. And then negative 4 plus 7
Plus 3.
positive 3. Now, are we done?
No.
No. Because we might be able to factor, and I tell you, we will be able to factor this denominator. So let's do it. First of all, there is a GCF. So let's factor that out. 2, and that leaves v squared plus 4v plus 3. Now, can we cancel, or factor, I should say, can we factor this trinomial? Yes. What does it factor into?
3 plus 1.
All right. Well,
Plus
let's use our common mathematical sense for a second. If there's a v plus 3 in the numerator, there's a good chance there's going to be a v plus 3 in the denominator. Will it always happen?
No.
No. But that's what I need to be looking for. And guess what? There is.
2v plus 1.
2 times v plus 3 times v plus 1. This 1, 3 times 1 is 3. 3 plus 1 is 4. That's how it factors. Now, I don't look at those anymore. Now I can cancel the v plus 3's. And what I'm left with is a 1 over a 2 times v plus 1. So make sure you don't forget that if everything cancels out in the numerator, there's a 1 left over, not a 0. Okay? So there's your final answer. All right, let's do another problem. All right, we'll pause it and let you do this one. Okay, so notice the nice thing about this problem is that the denominator is the same. Denominators are the same. So we're going to rewrite our denominator, 27x squared minus 54x. And then I'm going to combine my numerators, which is very simple. Combine like terms. 2x plus x is 3x. Negative 4 minus 2 is negative 6. Now, once I have it in its combined form, now I'm going to break it down by factoring. Always check to see if you can factor. So I'm going to factor my numerator. What's the GCF up here? 3. So I'm going to go 3 parentheses, and that leaves what?
2. X
minus 2. And then in the denominator, I'm going to factor out the GCF, which is 27x. So the 27x is our GCF. That leaves x minus 2. Imagine that. Huh.
And the x minus 2 cancels.
Dang it.
X minus 2 go away.
And then you got 3 over 27x.
3 goes into 27 9 times.
1 over 9.
So the final answer is
1 over 9.
1 over 9x.
That's a bad man, baby.
Okay, I didn't do it. I did.
I did something different
I
about it.
factored the 2x minus 4. I mean, I would have gotten the same answer, but
Yeah, you could do it that way.
I wound up getting a 2 over 27x.
I didn't do that
Because you factored out. Alright, so 1 over 9x is our solution.